I want to talk about how hot the world is going to get. This question is vitally important for people and for planet, but can be surprisingly tricky to answer. And now, one of YouTube's most famous science communicators, physicist Sabine Hossenfelder, has made a video on precisely this topic, drawing a devastating conclusion.
I feel like I need to tell you about this, because the lives of hundreds of millions of people depend on it.
So is Sabine right to be so scared? And how hot will our planet get? I'm Adam, a climate scientist with a PhD from Oxford, sharing what you need to know about climate change. And today I want to talk about physicist and YouTuber Sabine Hossenfelder. Well, not exactly. What I actually want to talk to you about is something called the climate sensitivity. But first I need to give you a little bit of a backstory. Sabine is one of this platform's most prominent science communicators, and actually I've corresponded with her before. For example, around this time last year we were discussing the greenhouse effect for a video she was making at the time. Sabine recently made a video called "I wasn't worried about climate change, now I am." As the title suggests, this video discusses whether we could be way more screwed when it comes to climate change than we previously thought. But I do think that some of the points the video raises could use a good chunk of extra context. I also think that there's a risk that viewers may have got the wrong impression at points about how we actually do climate science. And so I thought it would be a great opportunity to watch some clips from that video and explain some essential climate science as we go. And to make sure that I'm not jumping the shark, I also asked 3 experts in climate sensitivity for some feedback for me before putting this together. They're all, by the way, excellent science communicators, and so their socials are in the description below. Okay, let's jump into it.
Climate scientists are having an argument about a number, one single number called the climate sensitivity.
So climate sensitivity is this really evocative name, which I just love. What it actually refers to, and to give it its proper name of equilibrium climate sensitivity, is this kind of hypothetical concept. If we doubled the amount of carbon dioxide in the atmosphere and then waited for everything to equilibrate, how much hotter would the world get? But ultimately, this is just a metric that answers the question, if we add X amount of CO2 into the atmosphere, how much do temperatures go up by? In other words, how much is the world around us affected? And it's worth pointing out that actually climate scientists have been discussing this number for decades, and literally hundreds of studies have come out about climate sensitivity over the years. Pretty much all of these studies fall into one of 3 camps in terms of how they try to get an answer for the climate sensitivity. I'm not going to tell you what they are right now, but maybe have a think. If you wanted to work out how sensitive the atmosphere was to carbon dioxide, how would you investigate that question? What would you use to try and answer that question? And drop your guesses in the comments below. If you get all 3 right, I guess you win a prize of high self-esteem. Okay, next clip.
Up to 2019 or so, the climate sensitivity of the world's most sophisticated climate models was roughly between 2 and 4.5 degrees Celsius.
Okay, so I think it's worth explaining what climate models actually are. These are computer models that simulate the laws of physics and the things that govern the climate here on Earth. So things like how water flows around the ocean, how air moves through the atmosphere, how water vapor evaporates from the seas and condenses into clouds. And the reason they're useful is we can then take these physical models simulating all these physical processes and ask them to simulate certain situations. So, for example, what would the climate look like if we added a whole bunch of greenhouse gases to the atmosphere? Like that would ever happen. These models are pretty incredible, but they're definitely not perfect. And so climate scientists always treat their results with caution. And so while they're a part of how we try and work out the climate sensitivity, they're only one part of that equation. So keep guessing in your comments how we do actually work out climate sensitivity.
In the 2019 model assessment, 10 out of 55 of the models had a climate sensitivity higher than 5 degrees Celsius. That was well outside the range that was previously considered likely.
So here we're really getting to the heart of what the video from Sabine is all about. These models which get higher levels for climate sensitivity, and so basically predicting higher temperatures in the future. This sounds scary, and so the big question is, should we trust what these particular models are saying? Sabine's video argues that we should take what they're saying seriously, but as I'll explain to you in just a second, there's a really good reason that we should probably treat their estimation of climate sensitivity with a massive amount of caution.
If this number was correct, it'd basically mean that the situation on our planet would go to hell twice as fast.
Sabine's fantastic way with words at full flow here.
What's happened is that climate scientists decided there must be something wrong with those models which gave the higher climate sensitivity. They thought the new predictions should agree with the old ones.
So Sabine goes on to clarify this a bit, but you could definitely still watch her entire video and get the impression that climate scientists just chucked out this result because they didn't like it and they liked their old result better, or because they were scared. This is definitely not what happened. I mean, imagine you had a bunch of different climate models and you wanted to know which ones to trust for their predictions for future climate change. Well, what would you do? Again, feel free to comment that in the comments below, but while you're having a think about it, I just want to point out how hilarious I find it that hot models has such a fundamentally different meaning to climate scientists than it does to any other person in the entire world. Okay, enough of that. Let's talk about how you can actually tell which models to trust. Well, the thing is, the climate has already been changing over the past 150 years or so. And so you can say to the models, okay, well, here's how carbon dioxide levels changed over the last 150 years, and here's what volcanoes did, and here's what the sun did. And then ask the climate models what they think would have then happened to the climate over that period of time, and compare that to what actually happened. Similarly, we can go further back in time and look at the last ice age and ask the models to see whether they can recreate the conditions of the last ice age. When you do that with the hot models, you get bad answers. So, for example, for the recent warming over the last 150 years or so, the models predict a good chunk of extra warming, more than what we actually saw in the real world. On top of that, when it comes to simulating the last ice age, many of the models simulate it much colder than we believe it actually was. And so this is why climate scientists are skeptical about these climate models' predictions for future climate change, because they're bad at simulating past climate change.
In 2020, a massive study compiled all this paleoclimate data and found that it fits with a climate sensitivity between 2.6 and 3.9 degrees Celsius.
Okay, so this is a study that Sabine is then going to say later, maybe actually the climate sensitivity is quite a bit hotter than this. But first, let's actually look at what this study was actually doing. The first thing I have to point out is throughout the video, Sabine confuses what we call the historical climate, the climate we do actually have direct measurements for, with the distant past of climate change, what we call the paleoclimate record, which we can tell about because, for example, it left its traces in ice cores and tree rings and things like that. So here she's suggesting that this study is a paleoclimate study and used this distant past to study what the climate sensitivity might be. And she's really doing this study a big disservice by doing that. Because what this study actually did was say, hey, look, there are really kind of three distinct lines of evidence we can use to estimate climate sensitivity. And they are, drumroll please, looking at the recent climate change over the past 150 years, looking at natural climate changes over the distant past, those paleoclimate changes I was just talking about. And then on top of that, the third one, studying the physical processes that could either amplify or dampen the heating effects of carbon dioxide. And so instead of just looking at one single approach, what this study says is, let's look at all the approaches together. And that's how they come up with this number, 2.6 to 3.9 degrees Celsius. It's also worth noting that this approach that this study used is also used by the Intergovernmental Panel on Climate Change, the IPCC, who write these really important, really authoritative reports on the state of our understanding of climate change. But in both cases, the approach is basically to say, let's use all the evidence we can get to pin down this number, rather than just using one line of evidence.
The major difference between these hot models and the rest of the pack is how they describe the physical processes that are going on in clouds.
So this is definitely true. There's a lot we still have to learn about clouds. And so it's not at all surprising that clouds would be a big source of difference between different climate models.
There's one of the hot climate models that can also be used as a weather model. The newer model, the hotter one, gave the better forecast.
So what Sabine is saying here is that the hot model gave a better weather forecast than its non-hot counterpart. This is definitely a really interesting result, but I would say it's kind of academic, because knowing how to simulate the weather a few hours or a few days in advance is great, but it's a very different task to simulating how the climate will change as carbon dioxide and different greenhouse gases, etc., change over the course of many decades. And as we've already seen, the hot models aren't good at simulating how the climate changes as the conditions driving climate change. Okay, now we're going to move on briefly from looking at the models to a particular study that looked at the paleoclimate, so that distant past, as a way of trying to get to climate sensitivity.
They claim that the historical data is compatible with the climate sensitivity of 4.8 plus minus 1.2 degrees Celsius. That agrees with the hot models. I don't know who's right or wrong.
So here, Sabine is saying, okay, this study is supporting the hot models. It's hard to tell who to believe. What's really important to emphasize again is that there are hundreds of papers on climate sensitivity. It's understandable that this one got a lot of attention because it was effectively written by a climate scientist celebrity, Jim Hansen, who was actually the climate scientist who sounded the alarm to US Senate. That said, there has been a lot of critique of this paper from other climate scientists, and I've put some links in the description if you want to check some of them out. I can still understand, though, that people might say, well, how am I to trust these climate scientists and not James Hansen? And I guess what I would say is, again, there are just so many different individual studies on climate sensitivity, all with a slightly different approach. Lots of them also get results much colder. And so why not trust the cold predictions of climate sensitivity? Well, what I would say is surely much better than just taking a random study and saying, should I trust this study? Should I trust this study? Is saying, well, let's combine all the evidence that we have and try and make sense of it all together and use that to come up with our best possible conclusion. And that, as I've said, is exactly what this study does, and that is exactly what the IPCC, the Intergovernmental Panel on Climate Change, do.
The bottom line is that the possibility of a high climate sensitivity above 5 degrees Celsius can't be easily dismissed, especially not seeing how fast average temperatures have been rising in recent years.
I think the crucial point here to mention is that it's not being dismissed, it's just when you look at all the evidence together, you see that it's not very likely. I would also say that yes, the last few years have been, especially last year, absolute scorchers when it comes to global temperatures, but they don't lie outside projections that we've had for the trajectory of climate change, and they're not inconsistent with our previous estimates of climate sensitivity.
It just blows my mind how stupid it is that the lives of all people on this planet depend on an obscure discussion about the properties of supercooled water droplets in a type of cloud whose name I can't even remember.
I get this feeling, but there's a reason that this wasn't front page news, because actually the real story here is that climate models that have shown themselves to be bad at simulating climate change get weird results when asked to simulate future climate change, and climate scientists aren't taking those results so seriously. Now, obviously, that's not a very catchy headline or YouTube thumbnail, but that is ultimately what the story is here. Okay, I'm going to jump now to right near the end of Sabine's video, where she discusses her wish list of how we could combat climate change.
Put a price on carbon dioxide emissions now. Continue to expand renewables. Build nuclear, build nuclear, build nuclear.
So on this building nuclear point, for example, the International Energy Agency, in their net zero 2050 scenario, see nuclear power across the world just doubling by 2050, whereas renewables absolutely skyrocket in their role. And so nuclear absolutely could and probably will have an important part to play. But the way Sabine mentions it here, it might sound like it's the most important thing, which in most scenarios for how we get to zero emissions it isn't.
Stop bitching about carbon dioxide removal, there's no way around it.
Again, Sabina's wonderful way with words. I agree and disagree with this. On the one hand, it really looks like we will need, to some extent, carbon dioxide removal. On the other hand, carbon dioxide removal is often used as a kind of greenwashing and delay tactic by industries and governments who don't want to cut emissions now and are basically just saying, oh, it's fine, we can just remove the carbon dioxide later. Carbon dioxide removal is very expensive, very difficult to do, and so we can only really do it to remove the last little bit of emissions that we can't otherwise cut. Fair, we need some carbon dioxide removal, but it's also fair that a lot of people are complaining about carbon dioxide removal being overhyped, because that overhype is being used as an excuse to delay action.
And for heaven's sake, stop gluing yourself to things.
So I find this last point quite interesting because all the other points in her list are things she believes need to happen, but you can clearly see aren't happening at the rate that we would need them to happen. And so how are we going to shift both public opinion and political action when it comes to climate change? And it would be great here if Sabine doesn't like this kind of civil disobedience, if she pointed out the kind of things that she actually thinks could be useful to push for those kinds of changes. Civil disobedience definitely makes people dislike the protesters who are carrying out the civil disobedience, but it can actually make people care more about climate change. So, for example, one study carried out in America found that when people learned about these kinds of civil disobedience climate protests, Republicans weren't really moved, but both swing voters and Democrats cared more about climate change when they saw and learned about these kinds of protests. And so there's at least some evidence that it can be a valuable tool for shifting public opinion. That's actually all the clips from Sabine's video that I wanted to discuss. But before I go, I also wanted to discuss the title of her video. I wasn't worried about climate change, now I am. This could give people the sense that if climate sensitivity is low, there's nothing really to worry about, but if it's high, then we're in deep, deep trouble, perhaps even doomed. But crucially, we're not fine if climate sensitivity is low, and we're not doomed if it's high. Either way, we're already feeling severe impacts of climate change today. And either way, we need to act as soon as possible to stop emitting greenhouse gases, stop burning fossil fuels, to limit the impacts on ourselves as quickly as possible. I also want to point out that the biggest uncertainty for how hot the planet will get is not how sensitive the climate is to a chunk of carbon dioxide. It's how big that chunk of carbon dioxide is. In other words, how much carbon dioxide we emit. And we can choose to make that amount as small as we possibly can. Finally, I want to say that I understand being scared about climate change. A lot of the impacts are scary, but the fact that it's frightening doesn't mean that we're powerless to act on it. And actually, my last video was all about managing these complex emotions between fear and courage. And you can check out that video over here. Okay, until next time, bye. Added a whole bunch of fossil fuels to the atmosphere.